I'm Cristoforo Timpano, and I'm going to be explaining mobility of a mechanism. So before I go into explaining mobility, I want to clear up a few definitions. The first is, what is a link? Now, a link is a rigid body that connects two objects to each other for the purpose of transmitting force from one to another. Now, a link can have multiple nodes. The first type of link is a two-node link, defined by its two nodes, one here, to connect to two different objects. The next is a multi-node link, which has, as its name suggests, multiple nodes along it, which all connect a different rigid body. The next definition I want to clear up is, what is a joint? A joint is a connection between two or more links. There are two types of joints. There's a low pair, which is defined as contact between mating surfaces, like such. We have two different parts, and the mating surfaces. So this is a low pair joint. The next is the high pair joint, which has contact between point-point, point-line, or line-line, like such. Now here is a roller along a flat surface. There is a small point here that contacts the ground, which is a line, and thus it is a high pair joint. The final thing to define is degrees of freedom. Now, degrees of freedom is the minimum number of independent coordinates to define motion. So if we have a two-dimensional object or an object moving in two-dimensional space, we can have movement in x, movement in y, and turning. So thus, a planar mechanism can have three possible degrees of freedom. The next is a spatial mechanism, which can move in x, y, and z, as well as turn in all these directions. So we can have 6 possible degrees of freedom, and 2 and 3 here. So now I want to define a few of the most important joints. Now the first is the revolute joint, which is by far the most common, and this is a turning joint because it turns. It has 1 degree of freedom because it can only turn. This is also known as the arc joint. The next is the prisma joint. The prisma joint slides up and down a slot and thus has 1 degree of freedom and is a sliding joint. This is also known as the P joint and has 1 degree of freedom. The next, similar to the prisma joint, is the cylindrical joint, which can slide up and down, but it can also turn. So it has 2 degrees of freedom, and the C joint has 2 degrees of freedom. The next is the spherical joint. The spherical joint can turn in every direction. Thus, it has 3 degrees of freedom and is known as the S joint. Now finally, I want to explain a higher pair joint. So, we'll look at the pin and slot. Now the pin and slot has a little slider, a circular slider that moves along the slot. Now you would think it can only move in the x direction, so it should have 1 degree of freedom. But because it is a higher pair joint, it actually has 2 degrees of freedom, and this is very important to recognize. The POS joint, pin and slot. So now let's move on to mobility. So mobility is the minimum number of independent parameters needed to specify position. So what does this mean in actuality? So if I have a linkage mechanism, I would need 1 motor, if I had a mobility of 1, to have the system move. If I had 2, I would need 2. So mobility can be calculated by using m is equal to k n minus j minus 1 plus the summation of f, where k is equal to the number of possible degrees of freedom in your mechanism, which is 3 for a planar mechanism and 6 for a spatial mechanism. The next is n, which is the number of links, and j, which is the number of joints. Finally, f is the number of degrees of freedom of your joints. Thank you.